Hi, my name is Sagarika and I'm from Team 14383 Formula R. In this video, we're going to go over how to get started using OnBot Java, starting with the Android phone you use to open OnBot, to writing a basic TeleOp using the platform. Without further ado, let's begin the video.
So we're just going to start at the home page of the Robot Controller app and click the three dots in the upper right corner to see the drop-down menu, and then you hit the Program and Manage tab. So on this page, you should be able to see the name of the direct Wi-Fi for the phone. For competitions, you'll have to change this for certain specifications, but right now you'll just need to know the name. You can also see the password or passphrase for the network, and this is how you're going to connect the laptop you program to the robot controller phone. From here, if you hit the three lines in the upper right corner again and see the drop-down menu, you'll notice that the first two options are Blocks and OnBot Java. They're both programming platforms, but Blocks, as its name implies, is block programming, like Scratch or the programming for a Sphero, whereas OnBot Java is written code, using, again, as its name implies, Java. In this video, however, we will be focusing solely on OnBot Java, and you can click on either of these tabs to directly code from the phone. It's just very inconvenient. So now we're going to transition over to a laptop, open up OnBot, and begin writing a basic TeleOp.
So right now, I've just opened up Google Chrome on my laptop, and we're going to start by connecting to our phone. So we're just going to hit the little Wi-Fi icon, and you can see that the Wi-Fi name from our phone has appeared. So we're just going to connect to that, and it will ask you for the password, but since I've already connected to the laptop before, I don't have to do that. And we're going to enter the URL to open the page with first programming platforms. Again, I don't have to because I've bookmarked it, but to find the URL, you can just go to the Program and Manage page on your phone. So we're going to go onto OnBot Java, and as you can see, we have a home page, and we're going to hit Add File to create a new program. So for this file, we're going to call it my first TeleOp. And because we're writing a TeleOp, we will select that the op mode is a TeleOp. If you're going to look for any samples, then all you have to do is just hit the little arrow, and it will give you an entire list of samples you can choose from, and that is a great resource for those of you who are starting out. So we're just going to hit OK to create the program, and you can see that it has created the file. So what this @teleop right here means is that we'll show you what the op mode is. So if you had hit autonomous when you're selecting the op mode, it would say @autonomous. And if you had selected not an op mode, then it wouldn't be there at all. So in the first line of code right here, public class my first TeleOp, we're going to actually add a little bit to this line. And it's going to say extends linear op mode. Linear op mode. So what this does is it says that our class, or our child class, my first TeleOp, is able to access the knowledge from its parent class, linear op mode. And so the next thing to know is that we're going to write all of our code in between these two brackets. So you're going to start here with your next line of code. So just for formatting purposes, I like to indent after every bracket or brace, but again, white space in Java isn't that big of a deal. So the next line of code that we're going to type says private DC motor, and then you're going to give it a name like right front motor. So what this line of code is it's saying that a DC motor or the private DC motor is called RF motor throughout this program. And so this isn't just for DC motors. You can also do things like servos servo, and we could call it bucket. Say you were controlling a bucket using a servo, and then you can also do continuous rotation servos. So CR for continuous rotation servo, and maybe that controls an arm. And you can even do a color sensor. Private color sensor. And maybe those would be like the eyes of your robot. So you would put eyes. So because we have a right front motor, we're going to add in the rest of our hypothetical motors to create a 4-wheel drive with one motor for each of the wheels. So private DC motor, right back motor. Private DC, oh, I've capitalized it so it won't recognize it yet. There we go. DC motor, left front motor, and not protected. You can see when it comes up with these little keywords, you don't actually have to finish the word. You can just hit enter and it will finish the word for you. And private DC, oh, private DC motor, left back motor. All right, so you can see right here, it has given me an X, which means that there is an error in that line. So as you can see, I've once again capitalized private, so it says I have an error, and as soon as you fix that, the X goes away. So that's another thing that's great about OnBot Java. It's really easy to find your errors and to correct them. So moving on, or actually this is a great example. Right here we have a single line comment. So if you want to say what any line of code does, like right here, I would put you're naming the different parts of the robot. All right? Okay. So the next thing that we're going to do is the next line of code that we're going to write is, again, we're going to tab for consistency in our program, and we're going to write @override. So basically, this is just our beginning of the new code that we're going to write. And the next line of code says public void run op mode. So instead of having a semicolon after this, we're actually going to have another bracket or brace. And you can see we're going to have to type another brace because now there's 2 opening braces and 1 closing brace. So we're going to add another one of these, and we're going to start typing in between these 2 braces. All right. So the next thing you're going to do is you're going to connect the names that you've written up here to the names you've configured onto your phone. So if you don't know how to configure objects on your phone, don't worry, we'll have a video about that soon. So what we're going to do right here is we're going to put in the name of the part of the robot. So like we had RF motor, and we're going to set it equal to the hardware map name, which is a DC motor. In the hardware map, we've configured RF motor as a DC motor class. And in our hardware map, maybe we also called it RF motor. And then we're going to put a semicolon at the end of that. Remove paste just for consistency. So you can see that the name in the hardware map matches the name we've given it in the program, but that isn't always the case. So it can even be a small thing, like maybe in the hardware map you capitalized motor. But it doesn't matter because as long as you put the right name that you configured in the phone in between these 2 quotations, then it doesn't matter if the name here matches. In fact, maybe I just called it motor 1. But again, as long as it's the right name in the phone, it'll be the right name in the program. But let's say we've configured it as RF motor. Personally, I find that this makes things a lot easier because you're not having two different names between the phone and the program. So when you're referencing things in the program, you'll know that if you have to change any configuration in the phone, then it's the same name. So the next thing we're going to do is we're going to basically do the same thing for all our other parts of our robot, our DC motors, our servos, and our color sensor. So now that we've finished connecting everything to our hardware map, we're going to move on. Our next line of code will be sending our status to the driver station using something we call telemetry. So the way it's going to look is like this. We're going to put a space, again, just for formatting reasons. And we're going to write telemetry dot add data status running. So what this means is that your think of this portion of the parentheses as a caption, a sort of title and or question, and this being the answer. So if you're looking for what the status is, you know the status is running. So adding data is kind of like gathering what the data is going to be. And the next line, telemetry.update, is going to be sending it off to the driver station, which is the other phone you have. All right, so the next thing you're going to do is we're going to begin the while loop. So you're going to write while op mode is active and it says we have an error here. So, right. So we're going to put in our parentheses there. I almost forgot. And this is entering our while loop. So what we're going to do now is we're going to say that our double, and a double is just a variable, and we're going to give it the name right front target power is equal to 0. So we're resetting the value to 0, and then we're setting it to, so then we're going to say RF target power is equal to gamepad 1 dot right stick Y. So the difference between right stick X and right stick Y is that right stick Y controls the Y axis of the right stick, and right stick X refers to the X axis of the right stick. So what you're doing right now is you're setting the value of the variable equal to the movement of the gamepad joystick. And what that means is, say the driver was to move the right stick y-axis on gamepad 1 all the way to the top. That would be considered a value of 1, whereas the opposite, moving it all the way to the bottom, would be considered a value of -1. So what we're going to do is, now that we've set our variable equal to that movement, we're going to set the variable equal to the, or we're going to set the power of the motor equal to the variable. So what you have to do is you say RF motor dot set power, and you're going to put in within the parentheses RF target power. So once this is all done, you are technically completed setting the power of the motor equal to the power of the right stick. So you may be wondering why we didn't just set the power of the motor equal to the right stick in the first place, which is possible. But the reason you can use a double is that it makes it way easier to troubleshoot. And you'll see why in a second, because the next line of code is telemetry. So you're going to input telemetry.addData again, because you're gathering the information. And what you're going to do is the caption will be RF target power, and the answer, or the value that you're looking for, is whatever the power of RF target power is. So you'll notice that we didn't put this within quotation marks like we did when we were writing this set of telemetry. And that's because right here, the value or the answer we were looking for is a word, whereas here, we're looking for whatever value that the double is set to after it's been set to gamepad 1 right stick Y. So it's going to be a number. Oh. And then what we're going to do is just end it with a semicolon, and we're going to go into our, you can either put the telemetry update here, or you can put it at the very end once you've finished doing this this portion of code for all of your motors and your servos and your sensors and everything. That is, if you're using a sensor during TeleOp. I'm just going to go through and program. The programs for all the DC motors should look pretty much the same. It would be setting your double, the double equal to the different parts of the gamepad, and there are several. One thing I would advise is using the joysticks for anything that would need two directions of movement, like forward and backwards. And you can use the triggers for this too, but what you'd have to do is set one trigger equal to the positive movement or the forward movement of something, and one trigger equal to the backwards movement of the same thing. Or you could just use it if you only did a forward movement on something, and then you'd have two different motors, essentially, or continuous rotation servos. Servos, people generally use the buttons for, because they're setting them to positions. So you could say when you press the X button, the servo would go to position, for lack of a better variable, X. So we're only going to program one motor here, but we are going to use the triggers to program our continuous rotation servo arm. So what we're going to do is we're going to say, actually, yeah, okay, so I have a space, again, for formatting, double, and we'll just set this to arm target power. And again, we're going to set that equal to 0. And then you're going to say that arm target power is equal to gamepad1 dot right trigger. And again, end it with a semicolon. So this looks pretty much the same, but you'll see how it differs from our motor in just a second. And once again, we're going to add in the telemetry. Telemetry dot. Oh, yes. Sorry, I almost forgot to set it equal to our CR servo. So we're going to just say arm dot set power. And we're going to set it equal to arm target power. And then we're going to add in our telemetry. And again, telemetry.add data, and put in our value, which is arm target power, and the actual value, which is arm target power. You'll notice that I separated out the words for this one, but I haven't for this. It really matters. All that really matters is your preference and what you'd like to see as the screen shows up when you look at the driver station. So the way it'll show up is, if I can open up Notepad, it'll show up sort of, so say you have the first one where it'd say RF target power, then you'd have the colon, and then you'd put your value here. So say the value was a 1 because they pushed the y-axis all the way up to the top, or our CR servo would look more like this, arm target power, yeah, power, and then it'd give you its value, say 0.5. So that would be how that works. Or, yeah, 0.1, whatever you set it to. And that would be how it shows up on the driver station. So whichever one of those you prefer is really what you would use in your telemetry. Save. All right. So you'll notice when I was talking about how using a double made it easier to go back and figure out what's wrong with your program if something isn't working. And the reason for that is when you've put in the telemetry for your double or your variable, you can also put in the telemetry, so telemetry.add data for your actual motor. So you would say arm power. And that would be, oh, sorry, I forgot to put the within quotations. And that would be your caption. And your value would be arm.getPower. And what that does is not only are you finding out the value that this variable is getting from the right trigger, but how much the actual motor, or this continuous rotation servo in this sense, is moving. And what that allows you to do is see if there's some sort of discrepancy between the variable getting the information from the trigger, but the motor not moving, and maybe you could see that the motor was burnt or you have some other problems. So what we're going to do to make sure that this servo can move in both directions is we're going to actually add another double, but this time instead of calling it arm target power, we'd call it N for negative arm target power. And again, set it equal to 0, and basically follow the same pattern, except this time your double will be negative, and instead of setting it to the power of gamepad 1 right trigger, you set it to the power of gamepad 2 right trigger, but the negative value of that. If you're not sure what I mean, you'll see it in just a second here. So we're going to put negative arm target power equal to the negative value of gamepad 1 dot right, or sorry, left underscore trigger. So, and again, you're just going to do the same thing. Arm dot set power negative, or sorry, N arm target power. All right, and then you'll input your telemetry. Telemetry.add data. What is an arm target power? And then the value. And then your telemetry for your CR servo again. And you'll notice that we're going to set it to the same caption, and that's because you're looking at the same value. So you're saying that this value is changing when the right trigger gets pressed and when the left trigger gets pressed. Arm.get power. And so that's basically a full TeleOp. So if you have too many extra white spaces, you can get rid of them by just deleting the lines. If you would like to, you can see that these two are in the same line, but the corresponding brace is in this line. You can just hit tab and then everything is formatted so that it's all in the same line. Thank you for watching, and we'll see you all in our next video.